it's like say she's beautiful while wearing like excessive lines and a gray wig. Like you can be.
Real ugly.
But you're only 47 years old. It's not. I mean, it's old, but not that old.
It's like almost
Like, how
my
do you,
age.
how do you
All right.
get that accent? 'Cause you gave me like an old lady.
Let's go for it. Back in my day.
Well, that's like.
That's true. 47 isn't that old. Yeah, it's true.
I mean, it's
I'll just talk normal. Like, do you think your parents' voice now sounds much different than when they were?
My dad's 40. And your dad's like 60. No.
All right.
He rounds up.
So what's the focus of this chapter? You shouldn't have to look back to find the focus of this chapter.
Kinetics?
Rates, okay, which is the predominant study of kinetics.
I was gonna say solutions. But you're right.
You're a failure.
Hey,
I knew that.
I even worse than the teacher. He's really smart at chemistry.
But not good at relaying it to you guys, apparently. The rate laws that we've considered so far have been specifically focusing on concentration. You looked at all your rate laws that you did in your homework. They all had a constant and they all had concentration, correct?
Yeah.
Okay? Although that is useful, there's a more useful way of relating or expressing concentration as a function of time, which is what we're going to do today with integrated rate laws using calculus and integrals. No, we're actually not going to do the calculus, but that's how they get this particular equation. So I want you to open up your book and to look at some important things here. How many of you at least know what integration is?
So we're learning.
Oh.
You're learning right
I mean,
now,
I've heard the word.
right? Integrals.
I've heard the word.
That.
Is it 12.4?
I remember that.
Yeah.
Aren't integrals the opposite of derivatives?
Yeah.
So I remember a few things from calculus. I'm not
That was our first quiz.
on what is an integral?
That was like one of the
One of the two
What are you
basic
trying to
questions.
figure out with stuff?
Yeah. That
and what do you
calculus.
use to
Nice. Cool. Okay. What did I say? Page 552? Or I didn't say a page?
552 is where it is.
Okay. For the sake of our lack of ability to do calculus and time, what we have there is an integrated first order rate law. You see ln of A, which would be the reactant concentration, equals negative kT plus ln of A naught. What is the A to the 0 subscript? What is that referring to? Do you guys remember what that symbol means? Or have I never showed you, talked about what a little subscript naught?
Thank you.
No? Never? Okay. That means initial concentrations. So if you need to write that down somewhere to help you remember, the with a little 0 or degree symbol as a subscript, that's going to be your initial concentration. So when we're talking about a reaction and the rate of a reaction, that would be the concentration at the very beginning of the reaction.
So would that be just one of the, like if it's a, if it has two reactants, would it be them both added together?
Great question. For the sake of simplicity, we're only going to focus on one reactant
Decomposition.
equation.
Okay.
Yep.
Got it.
Okay. So some few things that we need to kind of look at here. Let's look at point 2 in the big bolded portion there. It says equation 12.2 has the form of what? You guys not know where we are?
No.
Number 2 in the big blue bolded section.
Oh, okay. Y with
Oh,
it's
what is
slope.
it? What is that
It's a
equation?
line. It's a slope line.
What kind of line? Well, I guess all lines are
Straight line.
linear. Okay, that's a
It's
dumb
a
question.
It's a linear function. Otherwise it's a curve.
Curved line, you can't have a curved line in here.
I mean, you can say that, the words, but
It's
it's a
not a
curve.
line.
It's not a line, it's a curve.
Yeah,
You can call it that, but that's not correct.
yeah, sure, all right. Anyways,
You can call it
so the point here is using integration, we can get an equation that relates concentration as a function of time in a nice handy dandy linear relationship. Okay? So you can see where we're going with this when we get to doing, we're going to do linear regression to essentially figure out whether a particular reaction is zero order, first order, or second order, just by graphing it. We won't have to do all the experiments or anything like that. Well, you're going to have to do a few things, okay, but you're not going to have to interpret a graph. Well, you kind of are. You're going to have to do so. But anyways, I just want to make note here that in this particular first order rate law, what is your y?
ln of the concentration?
At a specific point.
Yeah.
So that concentration there would be at a specific time. Okay, versus the A naught is just going to be at the very beginning. Okay? Another really important thing to note here, your X is your what? Which is time in this particular situation. Probably the most valuable information to know is what M is. What's M? Has it been so long since we've done linear relationships that
It's a slope.
it's a slope?
It's negative constant.
Okay? So what we're going to do is we're going to take some data, we're going to plot it on Excel, it's going to be able to give us the equation, we're going to be able to pull out what the slope is, which will tell us what K is without doing any math. That's nice.
It'll compute it all around for you.
Yeah. Yeah.
Here's just math.
Okay? And your B is your ln of your concentration at the very beginning. That's not as important as you see. So this is what it says. It says, thus for a first order reaction, if you plot the natural logarithm of concentration versus time, always is going to give you a straight line if it's a first order reaction. So let me explain. If you were to plug this all into Excel, plot it using the first order numbers, and it didn't give you a straight line, is it first order?
No.
No.
Probably be second
It'd be 0 or second. We're not going to do third order
or third.
reactions.
Oh,
Okay? And so when you can see where we're going with this, what we're going to do is we're going to take a particular reaction and we're going to plot it 0 order, we're going to plot it first order, and we're going to plot it second order, and based on which one gives you the straightest line, or the nicest line that fits the data the best, that's going to tell you what the order is.
Would 0 order be a vertical line? No, it's up there.
Well, I don't know what it would be not integrated. If the integrated rate law is, if it's a 0 order rate law, it'll be a straight line. The graph will be, because of the integration is a linear relationship. Because I don't know what the non-integrated curve would look like. Probably a straight line, because concentration wouldn't affect the rate. Yeah, I don't think so. I don't know. Speculation. Okay? And then number 3, they've got the integrated rate law in a different form, in the form of a ratio. That'll become important when we do the last thing today. Okay? You guys are ready to do? You're going to need to take notes as I go through. Do you guys all just want me to show it to you on Google Docs, or is that what you're most comfortable with? Or can I show you both, or what do you want? You don't care to see it on Excel at all?
Is it really different? Or is it just slightly different?
It doesn't take much time, so I can just show you both.
Okay.
This isn't one of your more difficult things, to be honest. Okay, so you should have this information in your notes, correct? Yes?
Yes.
Okay. Let's start with I'm going to start with Excel. Okay? So you're going to want to take notes. Even if you don't think you're going to use Excel, do it. Take notes. Okay? So here's what we're going to do. We need to plot a graph that shows your x and your y for a particular first order rate law. What did we say our x and our y was in our integrated first order rate law? What was our x? Let's start with that. Time. Okay. Now, something that's very important, you may already know this, but whether it's Excel or whether it's Google Docs, the first column will be your x, the second column will always be your y. If you flip them, you're going to mess it up. You might want to make a note of that. Okay, because you're going, it always reads an x, y. Okay, then for a first order rate law, what is our y? ln of A, and A is our concentration of our reactant. Oopsies. Okay?
Is that in normal parentheses? I'm sorry, I'm trying to read that. Is it in brackets?
I'm just trying to show you that x is time, y is ln of A. And I put parentheses around ln of A, but A is in your brackets because brackets is concentration. Right? I think you know that, right?
Yeah.
Okay. All right. Now it's pretty easy because we have all the x values, don't we? What are they?
Oh, sorry.
0, 50. Okay. Now we don't have the y. What do we got to do to find the y?
Multiply that by mx and add b. Alright, so
We have no idea what m is. How do we find y? What is y?
ln of
Okay, do we know a?
yeah.
Could we find ln of a?
Yeah.
Okay, so here's what I want you guys to do. Rylan, find the ln of a at time 0. Ben, ln of a at time 5. What? Sorry, time 50, you're right, sorry. Nathaniel, ln of a at time 100. Grant, 200. Emily, 300. And Annie, 400. Okay, and I give you like a space. Oh, I gave you a, oh wow. Never mind, they're already on there.
They are.
Oops, yeah, they're already on there.
Well.
Okay, well you can do the ln just to confirm, just to say you know how to do it. No, I'm kidding, you know how to do ln.
Press the button.
Okay, so what you see here, this is the initial data table that they give you. You wouldn't have this second data table. I think I just gave it to you for time purposes. Okay, so we would plug in our y. Now you guys realize that for 0 order and second order we haven't covered yet. X and y are going to be different for a 0 order and for a second order. Okay, just making that clarification. This is specifically for what order? First. Okay, so let me just do this. Alright. So your very first step for putting in Excel is just putting in the data. Second step, you're going to click and highlight the data. So basically click and drag. I'm sure you guys are familiar with that, right? Okay? Go up to Insert. Tab. It's an Insert tab at the top. Over in the tab, you shall see scatter. It's referring to a scatter plot. Click it with scatter plot. And you're going to just do the one that has no lines in it. Just the data points. Does that make sense? Should give you, oops, did I put one of these in wrong? That data table doesn't look good. Yeah, right here. You can change, it'll automatically change your points if you don't have to redo all of them. Okay, they look good now? How did that come in? Anyways, I'll make this a little bit bigger. So there's a graph. Everyone up to speed with us? Okay? Here's what I want you to do. You're going to right click on one of the data points. Near the bottom it says add trend line. Click add trend line. Trend line. Sorry. Okay, this will come up. Okay, at the bottom you're going to click two boxes. You're going to click display an equation. We want an equation. And you're going to click display an R squared value. And you're going to close it. And we'll give you this. Move it up to the top there. They gave you an equation and an R squared value. I can delete this, that's not important. We'll move this up here. Okay, so let me kind of interpret this for you. Anybody see that well enough? I need to blow this up a little bit more. Okay? First off, does anybody know what the R squared value tells you? How accurate it is. So, if you have an R squared value of 1, it is a perfect fit. Which would tell you that this particular reaction, or this reactant, is going to be first order. Okay? This equation is the equation specifically for this reaction, which means that we had an equation, our y we said was ln of A negative kt, is it plus ln of A? I can't remember. Yeah. Okay? Well, it makes sense why we have y and t, because we plugged in y and t values. So, what's our slope here? What did we say our slope was in this equation? Slope equals negative k. Right? This was our x, this was our m, this whole thing. Does that make sense? Okay? Well, what is our slope here? Can you not read that? It's 0.0069. So what's our k? Negative 0.0069. Wait a second. I think I goofed that. Yep. X, Y. Yep, that's right. So, Our K here, we were able to figure out was negative 0.0069. So what we could do is we could take the K, we could plug it in, and we could specifically solve for a time at a given point. So that's what we're going to do next. Everybody see in your notes, I'm not going to pull up the PowerPoint because you have it in your notes. It should say, using the data given in the previous example, calculate the concentration at what?
100%.
All right. So, we know that ln of A equals .0069. I think I did something wrong here, but I can't figure out what I did. Looks just like the graph. Oh, okay. That makes sense. There's a negative there. I was wondering, I'm going crazy here. Why are the K's values wrong? Okay. You can't see that. But there's a negative there, which means our K is positive. Okay, you're probably wondering why I was freaking out. It wasn't making sense to me. Which means this is actually a negative. Everybody see that little goof? And you probably don't know why it wasn't, because you're not seeing what it should have been. Which means in the equation here, your slope is negative, and we know slope equals negative K, so really your K is positive, not negative, which is what I said it was earlier. Does that make sense? Okay.
When you plug back in, it's still negative against negative.
Yes. So in this particular case, K is positive, but when you plug it back into the equation, there's a negative in front of it. Does that make sense? Okay, so then our time is what? What did we say? 150 plus ln of our initial concentration, which, what was it? 0.1? And you can solve for your concentration at that time, e to whatever that is. Why don't you guys do that?
But if you already know ln, there's a constant.
Oh, yeah. Yep. Yeah, so technically you would, since you already know ln of 0.1, it's that, you would just replace it. I should have maybe just done that.
Well, I know point one, question is plus.
So does anybody have what just this side gets you?
Yeah.
Really?
Yeah. No, it's negative one, negative 1.27.
I got negative 3 point.
That's the last one.
Huh?
Here, hold on, I'm gonna.
Making me nervous here.
Wait, I didn't do negative 0.0, so
Yeah, negative 3.3.
Okay, alright.
Yeah,
What did you guys do wrong?
I didn't have negative point oh
I
oh
didn't do
six.
negative.
Well, I did get that, I didn't get it right.
What'd you say?
Yeah.
Do,
Yeah, see.
oh,
Point oh three six.
I multiplied all
See
three.
everybody, does everybody understand why I have the E here?
Yeah.
Does anybody not understand where that came from?
It's the opposite of ln.
The inverse of ln, that's how you cancel out ln. So your concentration, you can figure out, because we fit an equation to a specific first order rate law, you can now figure out what the concentration would be of a particular reactant at any time you want. Could you figure out the concentration at time 100? How about 120? 123? How about 432.47 seconds? Could you specifically tell exactly what the concentration would be of a first order rate law reactant at any time you want it?
Yeah.
Yes. Okay? Now, this isn't overly difficult once you know what the first order integrated rate law is and how it relates to a linear equation, y equals mx plus b. Once you know that, you should be able to graph it and take the information from the equation and use it to help you solve a bunch of stuff.
So you're using Excel to find the slope.
Yeah.
Okay.
Yes.
So, why did you even go from negative to positive to negative with the slope?
I was just trying to show you that technically the m in this equation is negative k.
Yeah, so it's always going to be what?
So slope equals negative k. So when you, not always is it going to be negative, so it just so happens that,
But it's whatever the slope is.
yes. But k isn't whatever the slope
Yeah,
is.
negative k is.
Yeah, in this case, yes. Yep. We're going to find it a different order. It's not going to be, it actually is just going to be positive k. Okay? So, let me show you on Google Docs, or attempt to.
So if they don't give us the y values, we
What do you mean the y values?
like these.
The,
So you find the ln of these.
You just leave them.
Yeah, so the ln of this is that. The ln of, so yeah, in your homework, you're not going to be given the ln values. You will have to find them. Okay, and when we do 0, second, first order, you'll have to find whatever the y is for whatever order you're trying to plot. Now, here's something that I do want to say is pretty important here. For a test, and I want you to do this in your homework, I want you to put in a title, I want you to put an x and y axis title. So you're going to go to, I believe it's layout. You might want to take notes on this too. You're going to go to layout and you're going to put in a chart title. And it says it right here at the top. And since I already have it, for some reason put a chart title in, I can just click on it and change it. So, first order rate law. Okay? Then I could go to the axes and put a horizontal and a vertical axis. So, and there's a 1,000 different ways to do it. Let's just do that. Wait a second. Oh, sorry. This axis title is where I wanted to go. There we go. And what is our x-axis? Time in seconds. Okay, put in a vertical. It doesn't really matter, we'll do that. And what is our y? So, ln of, what was our reactant in this problem? N, okay. For simplicity, I'll just do that. I don't want to put in subscripts right now.
Dinitrate and oxide.
Yeah. Okay? So, for your homework and for a test, what I want you to do is I want you to, eventually we will do 0, 1st, and 2nd. You'll have to do all 3 and prove to me which one is the correct one. Okay, you'll have to put, and then I want you on the correct one to put a chart title, an axis, and axis titles. Okay? So now let me show you.
2 data.
Yeah, probably. All right, so here's a spreadsheet. You're gonna do the same thing as far as putting in the data. So that isn't changing at all. So we said our x's are 0, 50, 100, oopsie. 200, 300, 400. It's just this that takes. Oh, you know what? I probably could have just done this. Dummy. Oh, you can't. Oh, there you go. Okay. Just was delayed.
You don't have the, you get that with the X.
I don't. I just put that up here I just put that up here to show you.
Oh, okay.
You don't need it. Okay, so you're gonna do the same thing, I'm assuming. You're gonna highlight. Okay, you're gonna go to insert, which I think is identical to what we had to do on Excel. You're gonna come down and you're gonna put in a chart from the drop-down menu. Okay. Right? So that should pull up a chart, and obviously that looks nothing like what we want. So we have to go to chart type, and it's quite a little bit down. There's scatter. So we're going to go to chart type and find the scatter plot, similarly to what we did in Excel. So maybe it's more similar than I thought, just not what I'm used to.
Different locations.
Yeah. Okay, I'll give you that. Then I believe you have to go to customize. Following? And I believe it's series. Okay, and you can see there's your trend line. Click it. And here is your R squared box there. And I think in label is where you find your equation. So right next to your show R squared, there's a little label that says custom. You're going to change that to equation. And it gives it to you. I don't know how, can I make this look bigger? I don't, can I make, how do you make the font bigger on this?
There's 11.
Oh, right there. Change that to, well, that didn't do anything. Okay, so I have no idea, so you'll have to figure that out. So what you have here, it's a little bit different. It doesn't say y equals. You have to assume that. But that is virtually the same k, they just went to 3 sig figs instead of 2. But then they added e to the -3. So it's the same number. Okay? There's your x, there's your b, and then r squared equals 1. So they kind of put the equation on the r squared on the same plane. Okay? Then I think, again, I do this morning, maybe I should have done it this morning. I'm assuming when you go to horizontal axis, you could.
Well, just remember your grandma's.
Any idea, those of you who've used this, how to put in a chart? Oh, there you go, chart
I
axis.
didn't remember the data.
Put a chart title.
That's kind of.
Right, and then.
Well, it says that.
I know, but I'm not seeing it at the bottom.
Wait. Oh, that's it. Oh.
Oh, there.
There we go. So you have to click on type, go to horizontal axis, put in time, seconds. Vertical axis, ln of. Okay. Now, what I would do is I would put in whatever the ln, whatever the concentration reactant is. So maybe it wasn't as different as I thought.
So when you plug it back into the software, your negative K is actually just the same thing.
Yeah, your M is negative K, but it's not K.
So it just stays the same.
So it just stays the same thing.
Like that's negative. When you put it in the equation. K is.
Yeah, so when you put it in the equation, you leave it as it is. But if you want, if I ask you what is K, you would put.
I just didn't want to change it and then.
Yes, yes.
Wow. It's a bit toasty.
Now.
It's nice because Sanford's room was freezing.